and welcome to Desk of Ladyada.
Hey everybody, and welcome to Desk of Ladyada. We've got a triple packed show tonight.
Jam packed. We went out over the weekend, and our trips are part of the things that we do. We love sharing things that inspire us and things that we do and places we go. So we're going to show some of the Vintage Computer Fest photos and video. But first we're going to do InfoAge because we had a jam-packed show on Wednesday, so we wanted to get to that this week. And then we're going to do, from the Desk of Ladyada, the Great Search. And then we're going to roll into some other fun stuff. So Ladyada, let's jump in right away.
Right, that's right.
On InfoAge.
This week's item PI, brought to you by DigiKey and Adafruit, is from Innocent. Ladyada, what is this week's item PI?
They're not guilty, they're innocent.
Yeah, I like that name.
Innocenti. This is a German sensor company. I've never actually used their stuff before, so this is always kind of nice when I get to highlight a new electronics developer. There's a lot of small businesses or smaller businesses that make electronic components and sensors and doodads and good stuff, so I'd like to highlight them. So this week's InfoAge is from them. It is the IMD 2000 UART output radar sensor, 24 gigahertz radar sensor. So how do you want me to?
What?
How do you want me to tell you to go to the next slide?
Yeah.
Because usually I can poke you, but.
Yeah.
So this is what it looks like. So this is, you can see the 24 gigahertz antenna on the top. And then on the bottom row there, you see a 6-pin connector. And we're going to get to that shortly. Okay, so this is the data sheet. This is a fairly new product. It's a radar detector. And you can see on the right what it's good for. So it's basically like detecting motion, object detection, object counting. It's a 24 gigahertz radio. It can run off of 5 volts. It's good up to about, I think, 50 meters. Ideal range for detection is 20 meters. And we haven't featured a radar before, and I've never really used radars at Adafruit before. But people are pretty familiar with the concept of a radar. This great image from Wikipedia. There's even an animation that goes with it. A lot like sonar and even IR detectors, or even time of flight, kind of any kind of distance or object detection. You are sending some sort of wave, and then you detect the bounce. And when you're using an IR sensor, you're detecting the light. And time of flight, you're detecting the photons that bounce back. And with sonar, you're detecting the sound waves, the 40 kilohertz plus sound waves. With radar, you're using multi-megahertz, multi-gigahertz waves. Of course, usually the lower the frequency, the farther that they go, but maybe the less precise the measurement. So it's a balance. Radar has lots of bands. You can check out the Wikipedia article, which is really long, and it was kind of fun to read, all about different radar systems and what they're used for. What you probably are most familiar with, radar is, well, first off, it was invented, which I found out it was invented like in 1905 or so, and was actually used mostly for military applications, as you can imagine. Being able to detect a flying metal thing coming at your city from far away is really handy. You want to know before it shows up that these planes or these bombs are coming. And so that these were used a lot in World War II to detect planes, to detect boats, to detect submarines. And what's interesting about this is you can sort of see this is on a platform. It rotates around because radar, you're sending out the signal and you're reading the bounce back, but it's unidirectional, like it's only one point, a lot like LiDAR. And so you have to spin around if you want to get a 360-degree view, which is where the really common, air traffic control or, military radar, you see something like this where you're detecting, it'll often pick up like other atmosphere effects, but you can see little blips on the radar, and then hey, that's a plane coming into the airport, and to tell it to either come in or pause. And it's usually used, of course, nowadays in conjunction with GPS and other location. But like radar works really well. It's over 100 years old. It's time tested. We also use it for weather detection and other stuff. But probably what you as a consumer are really familiar with is a radar speed detection gun. This image also from Wikipedia. I never knew what they looked like, but this is, they have one that's taken apart too if you want to look at the image, but it's got a radar cone inside of it, and it bounces a radar signal, also about 20 gigahertz-ish, off of a car. And by measuring the speed and frequency that comes back, it knows the location, that it's bounced off of an object and how fast that object is going. This, of course, brought back flashbacks of this ad, which was in every magazine known to man. Like if you read Popular Science, this ad was in there. This is Mike Valentine, who made a radar detector.
Yeah.
Electrical engineer. Also interesting story. If you're curious, read about it. But he's an engineer, and as you expect, the radar detector for speed detection, you'd have a very sensitive receiver that would be listening for that frequency, and it would know, even if you detected a little bit, you'd know, okay, somebody's operating a radar in this area. But it's not a common frequency that you'd pick up. They're still making radar detectors, don't you know? Okay, so the question is, with sonar and IR and time of flight and even LiDAR, you're probably like, oh yeah, you bounce a thing, the wave off, you see how long it takes for the wave to come back, you divide by the, wave speed, the distance, right? And that's a really common thing you want to know with, IR, time of flight, and LiDAR. But with radar, what's interesting is because the frequency is so high, you can take advantage of the Doppler effect, and there's, this great Wikipedia animation. It's a thing that, as an object's moving, if there's waves emitting from it, like in this case a sound wave, a honking horn, as it gets closer to you, the frequency pitch seems to go up, and then as it leaves, it goes down. So like if you're familiar with sirens, that's why they seem like they have a varying frequency as they pass by you, but really it's one solid frequency, or one stable frequency, but the sound wave is compressed as it's moving towards you, and it's stretched out as it's leaving you. So the same effect can be used with that radar gun. It's shooting this 24 gigahertz or so frequency electromagnetic wave, and then when the wave comes back, if the object was moving, you're going to get some variations in the frequency. If you have a very good detector, you can, of course, use that to determine the speed of the object that you're bouncing the signal off of. Very cool, and that's how speed detectors work. So it's an interesting, thing that you don't get with IR, time of flight, or LiDAR or sonar. So I mentioned IR sensors. Compared to IR, radar is going to go much farther. It's not affected by ambient light. It's not affected by the color or reflectivity of the object. With time of flight sensors, these are less affected by ambient light, but they also, they tend not to go more than 6 meters, whereas radars love to go multiple meters and go very far distance. That said, you're going to get more precision out of a time of flight sensor. These can do about a millimeter precision, whereas a radar is going to, probably going to get you like a half meter or so of precision of a location. Once you get the really good ones. Sonar can go very far distances. I like sonars a lot, but one of the things that's annoying about them is the cone of the audio wave is quite wide. Even, this one has a little cone shaper to it, but even then the spread is quite wide compared to LiDAR or radar. And then, of course, LiDAR sensors, which, are kind of like time of flight sensors. They bounce a laser off. These are very precise, and they're kind of replacing radar, but they're still quite expensive and they're new. So, it's, yes, they're available, but, there's only a couple companies that make consumer grade LiDAR at the same price point as like a radar like this. So, this radar module is what I like about this radar module compared to others that you're like, oh, I can get like these $3 modules, off eBay or whatever. But those tend to give you a pulse width or sometimes a couple pulses, and then you have to like do the math yourself to determine distance and velocity if they do velocity. What's nice about these modules is they have a UART protocol, and so you don't have to do any math really. You just get data out and you can send it directly to your computer or your microcontroller or whatever using their API, which you have to email them to get. So I don't have it set up, but it is 250 kilobaud, so it is like a standard UART protocol output, and it can detect multiple items up to 50 meters away. And the pinout is even FTDI compatible. How handy is that? So if you do get this module, basically you can skip a lot of the analog front end work that you would normally do with low cost radar, and you get the data out and it's like pre-processed and formatted and ready to go. So that's why I would recommend this for if you have a product or project and you want to just kind of get going fast. Because if you get a low cost radar, you're going to have to spend a lot of time mucking around with the signal to get the data you want, and then maybe you're not even sure that it's quite good. Sometimes there's a high pulse and a low pulse, and you have to take the differential of it. So it's why you don't see people use radar that often.
Available on DigiKey. But
there's like 1,000 of them available, so you can pick them up, and then you'll have to register and to get an account to get the software. But apparently there's desktop software for Windows that you can pick up. I would highly recommend the company just make it available so you don't have to register to get it. But then, you could also get the API for the UART protocol and then use it with any microcontroller. You don't necessarily have to use the desktop software also. I think this is kind of like an easy way to get started with radar sensing for, people counting, for motion detection. Sometimes it can go through materials as well if it's translucent to high frequency gigahertz. So do check it out. I think it's a new kind of sensor that I haven't used before. I mean, it's an old sensor, but it's one I haven't used. But I think it could come in very handy when you need that precision, range, and of course velocity measurement.
All right, and we have a video. It's about 2 minutes. We're going to play it.
The abbreviation radar stands for Radio Detection and Ranging. The radar emits electromagnetic waves which travel at the speed of light. These waves will bounce off objects on their way, and a part of the energy will be reflected back to the radar as an echo. The radar can precisely measure movement, velocity, direction, presence, distance, and angle of an object. We offer you a wide range of solutions for a vast range of applications. Let's start with home automation. With radar-based touchless switches, we make your home more comfortable and energy efficient. Radar systems from us are not limited to basic motion detection. They also perform tasks like speed measurement, vehicle counting, and classification. Our radar-based motion detectors and barriers are not limited to indoor security. They also ensure complete perimeter protection for critical infrastructure outdoors. Autonomous machines equipped with radar detectors scan their surroundings, navigate around obstacles, and avoid collisions. Our radar modules open doors and gates. They can precisely measure your sporting performance. And in driver assistance systems, they help you drive safely. In this example, the level of fluids or bulk material is measured in a contactless manner. The general advantage of the radar is that detectors can be integrated invisibly behind a wide range of materials. This makes them robust against environmental influences and vandalism. Good to know, radars work in the dark as well. Works in any weather. Works in extreme conditions like heat, dust, steam, and dirt. We are a market-leading, cost-effective manufacturer of radar sensors and radar systems in high volume.
And that is this week's Eye on NPI.
Eye on NPI.
Okay, some questions. First up, could this work for a custom slow down sign?
Yes, I mean it can be used for speed detection or object detection.
Okay, next up, is the speed of the UART protocol slow enough to bit bang and it uses the STEMMA QT port?
No, it's UART.
Okay. Speed of the UART protocol slow enough to bit bang it and use a STEMMA QT port?
Nope,
okay.
It's UART and you should use a hardware UART.
Okay. All right, so let's jump right into the next segment. Are you
Okay,
ready?
let's
We're
go.
going to do the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, this week's great search brought to you by DigiKey and Adafruit. Ladyada, what is the great search this week? Adafruit.
Okay, so this week we're going to look at RF capacitor kits. It's a handy thing which I don't have, and so I was actually looking for one today anyways to purchase. So let's go to the overhead. So I was chatting with Unexpected Maker about the ESP32S3, and one of the things they mentioned is, that they're sending us these new boards, the ones that we put in, that have a better RF Pi network. And it actually gave me a hint to understand why my ESP32 QT Pis weren't working. I thought that it was the RF signal was too strong, but it actually turns out I think the Pi network is mistuned. And he mentioned like, oh yeah, I just had to kind of try a couple different values and do some math and do some analysis and use a VNA, which I'm totally into. But before you hook up your VNA, and after doing the math and while you're doing the VNA tuning, what you want to do is be able to swap out the Pi network, which is usually made up of inductor and two capacitors. And the inductor and the two capacitors are like very small values, and they're very precise. Usually the capacitors are like 1 to 4 picofarads, maybe 5 picofarads, and the inductor is usually like a nano henry or 2 or 3. So having a kit, because you want to try multiple values, and the capacitors can have some variation. So you're not going to try like 2.2, 2.3, 2.4, because it's going to be plus or minus 0.25 picofarad anyways, variation per component and on the PCB and depending on humidity and stuff. But you do want to try very close values and see if you can tune your antenna and your network as close as possible. So having you could buy strips of cut tape, but it's better if you can just get the a kit that gets you all of them. So why don't we go to the computer, and that way
Sure. Gonna go to the computer in just a sec. Sorry, got a bunch going on today.
That's right. Okay, that's why I can go to here, and
Yeah.
you can keep on top of your stuff. So I just searched for Capacitor Kit. So this is the NPI. It's a cool radar. So DigiKey has a bunch of resistor and capacitor kits available, both through hole and surface mount. This time I'm just going to look for the capacitor kit, and there's a couple things that I'm going to be looking for. So first up, let's go only for active and in stock right now, because I'm only going to buy one, and I just want to buy whatever, I want to make sure they have it. I want to make sure it's an SMT component. I don't want through hole, because I want, the small capacitors. They have, electrolytic cap kits that are like, every big value or ceramic. Next up, so the capacitance range is a little bit tough to go through. I mean, I definitely don't want these larger ones, but it's also like they're kind of intermixed, like there isn't a start and end. So what I did instead is first I went to the package, and I don't want a package range. I only want 0402, because 0402 is a very common, small enough to not have size effects, but large enough that you could hand solder them if you wanted to. Some people use 0603, that's also fine. I tend to use 0402 for RF signal stuff. Don't forget that there's the imperial is 0402, which means the metric is 1005. And by selecting that small size, it actually limited the ranges already, because it's like you're not going to get a 10 microfarad cap in 0402. And then with tolerance, what I normally would want is to only pick C0G or NP0 tolerance, but they don't have that here, and so they do this by like percentages and stuff. So what I want is pretty much anything that's, I don't want it to be 20%. It should be 0.25% or less tolerance variation. And now I can actually look at the capacitance ranges. So they have one that's 0.05 picofarads to 0.075. That's too small. They have 0.1 to 22, which is kind of small, but that's still within my range. I want kind of like 1 to 10. This range looks good. This one's too big, and this one starts too high. So, you know, these two are too low and these two are too high. So, like, this is a nice start. So let's apply and see what's available. So there's a couple of ones available. Not surprisingly, there's ones that are from each company. So Murata, you know, makes a kit. You know, it's C0G. You can see in the photo, 0.1 picofarad to 5 picofarad. That's a nice looking kit. I actually thought that there's a couple kits I thought that were nice, but this one was not too bad. It had some. It kind of has a mix of both small. Like I like doing the look over because you can see it goes from 0.2 picofarad, 0.3, 0.5, 0.7, 0.9, 1, 1.2, 1.5, 1.8, 2, 2.2, 2.4, 2.7, 3, 3.6, 4.3, 4.7. 5, 6, 7, 8, 10, you know, so it's like, it's kind of like larger, goes to 30 picofarad. This one has many, many more values. It has like every 0.1 or 0.2 value up to 6.8 picofarad. So this is actually the kit I ended up thinking I'm going to get. Another thing about this kit that I like is it only goes up to 6.8 picofarad, and I tend to be dealing with 2.4 gigahertz, which is like the range I want. What I would first do, if you're not sure, if you're using other frequencies, look at a common Pi network for that antenna, like 50 hertz-ish, and see what the range of capacitor values are, because you might need larger caps as you go to lower frequencies. These are all good kits. You know, some are going to be, like this one also looks really great. This one's a DigiKey brand one from Taiyo Yuden. 25 values, 10 pieces each. 10 pieces is a smallish number, I think, just in case you're doing a lot of soldering and desoldering. Because, like, honestly, the 0402s, like, I kind of lose half of them. Like, I grab them with my tweezers and they fly off. So that said, I think this one's a good one. S402TS. So I would pick this one, grab one of these, and then I'm going to use this as I tune this Pi network on the ESP32 Pico.
All right. And that is this week's Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, while I talk about a video segment that we started this week, Ladyada is going to plug in the beautiful computing module.
Connection machine.
Connection machine.
Okay.
I call it the computing module because
Well,
I'm tired
it's
and I'm blending all the words. Okay, so this is
I plugged it in.
yeah. So we have a new segment called Chip Shortage, and here is a speed up from the show where we will each week show what chip we can't get. As you can see, zero stock, and it was Bosch this week. And we also have a really cool intro song, so I thought I'd just play that real fast. So that'll be every Wednesday from now on until the chip shortage is over, which is probably in about 18 months. Okay, so let's go to you, and
I'm going to hold this thing up.
look at this.
This is actually with the Pico inside of it, because it's just doing the random LED, but it's like, have you ever wanted a connection machine for
Yes.
your Barbie doll? You're set. She can now do all sorts of
My
machine
first
learning.
supercomputer.
My first supercomputer. Yes, designed by Thinking Machines. A gorgeous machine that we saw in person. Trammell Hudson reprogrammed the LEDs when it was at the MoMA Museum for a computing design exhibit, which was really awesome. But we thought, wouldn't you want to have something like this on your desk? And it's got like the vents, and it's got like this cool, shiny, metallic print. You can fit a Raspberry Pi 4, which is hard to get, but if you happen to have one, Raspberry Pi fits in it, and you can do a little bit more complicated LED patterns. Or this has a Pico, You just need the code is I think Arduino compatible, so you just need something. To be honest, anything with 2 I2C ports because you have to. You can only address 4 of them on one port because there's not enough I2C addresses to go around. But it's lovely.
Yeah, go to the Wikipedia page real quick, and then we'll show the Wikipedia page with it, and then you can hold it up in the little small version.
So
of...
you want to see the connection machine?
Yeah, go to that because they have a good photo of it there.
Okay. Yeah.
Okay, now
This is the CM2.
Yeah, so now there you go. So it's room size, it's pretty big. And now hold up the one that we made.
Not bad.
Pretty close, right?
Pretty close.
Yeah, not so bad.
Yeah, I mean the number of LEDs is a little different, but it's a very good facsimile. We even got the little the triangle vents that known Pedro really liked. So
next up, we're gonna wrap up our show with where we went yesterday. But first, a question. If the SAMD and NRF chips are unobtainium, is there a chance of an ESP or RP2040 circuit playground board?
The RP2040 isn't a very good candidate because it doesn't have a lot of analog pins. And the ESP32 is okay, but it's much higher power. So there's trade-offs.
Yeah.
ESP32 S3 might be a good option because it has Bluetooth, but it's a very new chip. And, of course, ESP doesn't have make good support.
Okay, so yesterday we went to the Vintage Computer Festival East, which also had the InfoAge Museum. And we posted almost 300 photos and a video today. Ladyada, maybe scroll through and just talk about some of the ones that you enjoyed.
Sure. Yes, this is in reverse order, but there was a great computer history and radio history area. There was a working Pong machine, original Pong machine. A lot of old computers. This is kind of interesting. This is the, I don't know why Twitter's so low. This is a 1958 analog computer. This, I believe it, I was talking to a friend, and he mentioned this had the first op-amp ever made, which is a Philbrick op-amp. It was created, or maybe it was created for this computer, but this is an analog computer, and of course it had the first op-amp. It's not working, but they're working. I think they're trying to get it up and functional. Other like cool. I love like some of the graphics effects. The IBM Think logo, classic stuff. A lot of teletypes. A PDP-8 classic. Working. You could program it if you wanted to. A lot of orange. A collection of different mice. This was funny. This was a like in situ recreation of a 1980s Commodore 64 owning teenager, who would have a Miami Vice poster, like a plastic ficus tree, and like a rotary phone, and a terminal printer, and like a weirdly comfortable chair, and some figurines from the new movie Star Wars. So, and a Monty Python video. So, good stuff. A lot of keyboards, some Heath kits, a Commodore PET, which is actually as adorable as I thought. Also has this totally gorgeous ortho keyboard, which you can check out. Just like ridiculous. They had a Apple Lisa and a Apple III. Two things that are hard to get. There was a working Next Cube. A couple like Data General, a Baybox that was working, a Cray. So they had a lot of the weird stuff. It's like, I've seen a lot of like, oh, here's a retro computer collection. It's like, okay, you got like a K Pro and like a couple Commodore 64s and like, ZX Spectrums. But they had the really weird shit, which was, I think, very impressive. Like very old, very rare, hard to come by stuff. There was also a military museum with some really cool old military equipment and radars and radar jammers. We also went to VCF and saw some of the setups there. People had various computer kits and setups, phones, custom Macs. This was interesting. Some fellow had like old French computers and French software. Like there's a whole other like Galapagos island of computers that France invented and like never really left that country. Like I've never heard of the Alice computer. So it's cool to see some of that stuff. Keyboards, lots of games set up.
There's a check
Weird history.
by Steve Jobs that he personally paid for some parts for Tektronix.
Yeah, so this is cool. You can see it's canceled on the back.
Yeah.
For $9.18
Yeah.
to Tektronix, which is down the street. A lot of core memory, some clear Apples and Macs, books, power books, tubes. The radio and telephone and television museum was, I think, the best part of the whole show. And they're open all the time, but they had a ton of telephone and radio and tube amp history. And the best part is, like, as Phil will attest, whenever I go to museums, I'm always like looking closely at stuff, and I always get yelled at by the staff because they're like, "You're too close," and I'm like, "I want to look at the thing and see the detail." Like the whole point of seeing it in person is it's not on the screen where I'm like limited by the resolution. I can actually look at the texture and like how it's put together. The cool thing about this museum is there's a lot of stuff you could touch that they were like, "Go ahead and touch this," and then there's a lot of stuff that while you can't touch, there were people who were running the museum and they would like open things for me or like show, like they'll take stuff out of the box and they'll like mess with it a little bit if you want. So, and as long as you're like not destructive, they might even let you play with it a bit. So there was a lot more tactile interaction, which I thought was really great. One of the things I understand a lot of stuff's delicate, but it's like, if there's a teletype there, you want to type on the teletype, and there you can type on the teletype, and you can tune in the radio, and you can play with the theremin, and you can, see the phone switching network go, and they had old radios and televisions you could play with. So as long as you're gentle, they were pretty chill. There's also a hacker space there. We saw some
Lots of Adafruit kits there.
It has some Adafruit kits.
Good collection of Make magazines and 2600 mile jobs.
Yeah, there you go. The first issue.
Yeah.
And then there's also this is, I guess, it's on Marconi Road. There's also a really cool dish, which apparently you can go and you can tune and listen to signals.
Yeah, we're gonna go there again.
So we didn't get to see that. We had to keep going. We didn't get to go in. And there's a Apple II lab, which I'm not exactly. I guess I don't know. They take 8-year-olds and they're like,
Here you
you're
go,
trapped.
kids.
You're trapped in Stranger Things time.
Look, it's just like your iPhone. It has an Apple logo on it. Look, it's like an iPad, but different.
It's an iPad.
Okay, so check that out. I put
Yeah.
all the links in the chat and more. So, we take photos for all of you. We don't take it for the world. We take it for our community and our friends. And so we thought that y'all might enjoy these. Specifically, when I hold up a camera, the lens that I have is, I wonder what, like there's like 100 people in my head that I'm like, I think they might like this.
And we didn't even get photos of everything. We really had to kind of rush through.
But that being said, this is the most photos I've ever seen posted of the museum so far. And I thought that would maybe help them. This is a jewel in New Jersey of knowledge and sharing. And the people there are very dedicated to sharing the history of how we all got here.
And this isn't even including the Jeep and Tank
There's
Museum.
Jeep, there's military, there's
there's
a lot of stuff there.
If you or your kid is really interested in military vehicles, and I know some people who love that shit, there is like 3 warehouses full of restored World War II plus.
And even if you don't,
World War I, World War II, and etc.
Even
military
if you
vehicles.
don't, it is so good to expose yourself to all the different ways that we built things in history.
Yeah.
So
there's also a tank ride. They'll
yeah,
actually
so
ride you around in a tank.
I'll give you an example. Like there is a pretty modern Jeep there, and it has a tactical nuke on it. And I'm not into tactical nukes so much, but it was really neat to see, like, oh, that's how they mount a tactical nuke to a Jeep.
Intense.
No, it was cool to see how all this stuff works and to understand it. Doesn't mean, like, I want to get a Jeep with a tactical nuke. I don't think that's an option at my local dealership. I will find out. But we'll see. So, anyhow, that's all the stuff that we have for
museum.
this week. All right, Ladyada, that was a really good jam-packed show.
I know, 45 minutes. But it was great
Good
to chat with everybody, and thanks for tuning in. Check out this week's 3D print, which is this, of course, gorgeous Connection Machine 2 that sits on your desktop and can house your Raspberry Pi. We're going to be back with live shows this week. We'll be back on schedule with Wednesday. JP's out this week, but we're around. 3D Hangouts is around.
Yep, and we're
We
doing
have Deep Dive with Foamy Guy.
yeah, and we'll be doing chip shortage.
Chip
All right.
shortage.
So I'm gonna, as we play out, I'm gonna
Chip
play
shortage.
a video that is. Let's see how long it is. It is. Where is the video?
Which video?
I have a little video of the. Oh, here it is, the Vintage Fest. So
Okay.
I'm gonna play out with this. So just.
It's like a minute.
No, it's 3 minutes and 56 seconds.
Oh, okay.
All right, enjoy,
All right,
everybody.
have 4 minutes of fun.
See ya.
Bye, everybody.
Makes us speak value that Dr. Face or stabilize to topic or three topic line or speak parameter that just type that is speak parameter things makes us speak value please select an option. Type A phrase and I try to save it. Adafruit.
Do I want the power-ups? The joystick works. Oh, yeah. I'm killing Oh, no. Bam.
Alert, alien craft advancing.
That's very good.
Alert, alien craft advancing.
Can you dial tone?
Very simple device. That's true.
Well, you can't
Oh, there you go.
Very simple
1223.
device. Yeah, right.
Well, that's awesome, Neil. I also own a TS520. It's not the, I don't know if it's the SC or not.
Bring.
Haven't ran it in a while, but that's one of the better rigs Ken will ever make.
Hello.
I will say,
Hopefully that will be with you
this
for long.
is the hardest exhibit to get kids away from. I had to take all the finish off and refinish it.
Do you want to call Nana from what?
Hi, Dad. Are you here?
It doesn't work.
That's okay. This is all for show, anyways. Stick to. Do you want me to sing the new song?
Never a lesson. Yeah, do it. All right.
New, 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 new. New, 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 new.
Right back there. Thank you. I'll wait a little bit longer. Just a